Hi and welcome to Workshop 7. This is the video demonstration for what's called Demo 25, which provides invariance tests for a measurement model. And for this, we're going to use the INP file called w7_demo25 config command. So in this example, I'm using simulated data from a course taught by Dr. D. Betsy McCoach from University of Connecticut to support the pedagogy. I'm using the simulated data because I'm interested in showing how to use the configure command in Mplus, and I want to demonstrate that. So this example has 9 indicator variables and 1 grouping variable, gender. So we'll start just by looking at the 6 indicators, V1 through V6. So using the model equals configural command provides a shortcut in which Mplus defaults are used to establish the model structure between the 2 groupings. So in other words, it makes sure that all the indicator variables that are used as marker variables in factor means they're set, but everything else is freely estimated and is different between the 2 groupings. So let's look at the syntax. All right, so here we are. This is Demo 25, and here I have a file w7_demo25. The format is free, type is individual, and there are 2 groups. So you have to say that in your data step, and then you say what the names of the variables are. The grouping is called gender, so that was the last variable listed here. And again, when it's 1, we call it male, and when it's 2, we call it female. And then we have, we're only going to use variables V1 through V6 and gender at this time. The analysis step, we're actually saying model equals configural. So that sets up default values for Mplus as to how this model will be estimated. All right, so I'm going to run it. You can't see that, can you? Okay, run it. All right, so now I'm going to go ahead and look down. And again, we're going to have all the model fit information as normal. And just another comment that I did do an identification analysis, and it's in the Excel spreadsheet, similar to what I did with Demo 14. All right, so here we have the loadings for the group male. So that's the first group. So we have F1 by V1, V2, V3, F2 by V6, V5, V4. The first item listed is the indicator variable. We have a correlation between the 2 factors. In this group, the means are set to 0, intercepts are estimated, variances are estimated, and residual variance are estimated. And in this case, we have, let me see here. Yeah, those are pretty much everything is different. And the only thing that is the same is that the factor means are set as 0, because that allows us to estimate the intercepts. You have to have one of the 2, otherwise the model is not identified. All right, so that is the configural model, but it fits. So you see that it has, this is a not significant chi-square, so that means the model fits the data well. But, okay, so that's great. So there is configural invariance between the male and the female, but records in this particular file. But now let's look at to see what would happen if we want to constrain some of the values. So I'm going to look at what's called W7 Demo 25 constrained. And in this one, the loadings for 3 of the indicators are constrained to be equal, and the factor means are constrained too. But because it is not mentioned in the female model, the same constraint applies to the female model. All right, so let me go through and to explain what that means. So everything here is the same all the way up to here. So now I'm putting the label, which is the something, a number of some sort that's in a parentheses, which identifies that this particular item, this particular loading is going to have a label. And as I look down at the female model, it has the same label. So that says that this loading for male and this loading for female are being constrained to be equal. And these two similarly. Although I am constraining the factor intercept, see, you have the brackets there, so that's an intercept. All those are being constrained to 0. I don't have it in the female part of the model, so therefore they are freely estimated in that part of the model. All right, so I am going to move this up so you can see that I'm hitting the run. All right, so I'm running this model. Everything looks good. Again, I can use this chi-square test of model fitness, but I want to take a moment to look at these. So this is group male. These are the loadings for the measurement model. And what did we have up here? Let me double check here again. Oh yes, we have F1 by V2 should have the same loading between the two models. So let's look down here. F1 by V2 1.035, and the female model, there it is, 1.035. So we're good. All right, so I'm not going to go through and check all of them, but there are some values that are freely estimated and that some are constrained. And so this is an additionally more constrained model than the configural model. So we want to know if there, even with this model, is there invariance? So I might have a theoretical reason why I think those would be the same between the male and female. And so if I'm going to use that measurement model with my data and I want to test some comparisons, I need to make sure that the model has this invariance. So by looking at the chi-square test and doing a chi-square difference test, I can tell which model fits better. So I'm going to go back to my model fit comparison spreadsheet, and I'm going to move this a little bit. Okay, so that's demo 24. Here's demo 25. I'm going to pause for a second. All right, I paused so that we would be able to see this entire spreadsheet. So here is the chi-square for that demo 25 configural command model, and here's the demo 25. We had those additional constraints on the factor loadings. So again, these are exclusively measurement models. We haven't done anything else. We're not testing any theoretical connections, any associations between these factors. These are exclusively measurement models. So when I do the comparison, and again, look at, you can see it. There you go. So when we look here, we see that this is a difference in the chi-squares. It's a difference in the degrees of freedom, and that's our p-value. So here's our notes. So when the change is not significant, we prefer the simpler model. Which one is the simpler model? The simpler model is the one with more degrees of freedom. So the constrained loadings model is not statistically significantly different from the configural, and it has more degrees of freedom, so we prefer the constrained model. So therefore, we know that using the measurement model and the constrained model, male and female are invariant, so this particular model and these instruments are invariant by gender, which is a very important quality to have. Once again, the file Workshop 7 model fit comparison, it's an Excel spreadsheet that I'm showing here. That contains the calculations for the chi-square differences for demo 23, 24, and 25. It also contains the model identification analysis from demo 24 and 25. I had to do this to make sure that I understood exactly how to write the syntax for the models. So by showing you this, I'm just giving you this hint that when you're doing your own work, you might run into difficulty getting the models to set up exactly the way you want. Okay, that's it for me. That's Demo 25 and Workshop 7, and it's a wrap. Thank you so much.